Hello and welcome. This is going to be a quick tutorial on how to make a node that will allow us to use blueprint code on a worker thread. This is something you might need if you have some long-running functions and you don't want to clog up your game thread. An example of this might be AI logic for a game like chess. So first thing we're going to do is demonstrate what happens when we don't use a worker thread. We just use the main game thread, and what I'm doing is I'm just calculating the first 2,000 primes, and it just completely freezes the game when you try to do something like that on the game thread. We get all of our UE logs at the bottom after it's finished. We go over here. This one's set up so it's going to do the same function except on a worker thread, and we are able to just keep playing the game as it does its calculation, and then gives us a little signal at the end. And this is all thanks to this little node that's only about 20 lines of code in C++. Be able to do this. And so yeah, let's dive right in. So I've gone ahead and made a third-person template C++ version in UE5. Pretty familiar. And what we're going to want to do is go and make a C++ class. Go to all classes. It's going to inherit from blueprint async action base. This guy right here. And we are just going to call it async action node. I don't know, something pretty generic. Can be public, that's fine. Create class. And not much here. First thing we're going to want to do is come up to the top, and we're going to want to declare dynamic multicast delegate. Call it ftask output. It doesn't need any parameters. Underneath generated body, we're going to make a section that will be public. And we're going to make a U property, blueprint assignable, ftask output. We're going to call this one multi-threaded work. And make another one, U property, blueprint assignable. And this one will be called, well, ftask output. Got to do the type first. It will be called finished work. Cool. Two of those. We need a U function that will be blueprint callable, and also have meta equals blueprint internal use only equals true inside quotes. That's going to be static U async action node multi-threaded node work node can be the name of it. And finally, we're going to need a virtual void activate. And that is an override. So this is all we need for the header file of our async action node. Underneath that, I'll make a little separator. And with that, we make a new class. And this one will be, we'll call it BP, non-abandonable task. Real creative. Inherits from public F non-abandonable task. And in this, we'll need a public section. Let's make a constructor, abandonable task, and the constructor is going to take in a uasync action node pointer. We will call that BP task instance. We're also going to need a destructor, That doesn't need any parameters. And then we got to do this thing for UE4, or UE5 rather. Force inline t stat id get stat id const, and then inside that we want to do return that one, return quick declare cycle stat bp non-abundant task in stat group underscore thread pool async tasks. That's just kind of something you need. Other than that, in our non-abandonable task, we'll have async action node pointer. We'll call it calling object. Initialize that to null pointer. And other than that, we just need void do work. So I'm going to go ahead and just create the implementations for these using Visual Studio. So first one we need is this function right here, multi-threaded node. We'll create an implementation. We need the activate, create an implementation. I'll do a little separator again, just so we see that some of the code is in the async part and some of the code is in the non-abandonable task. We need the constructor for this. We need the destructor for that as well. And then we also need do work, and that will do it. Do a save. So what do we need in the multi-threaded node constructor? We need async action node pointer. We'll just name it node equals new object of type async action node. You guessed it. Return node. So that'll do it for that. Inside activate, we want to do a new f auto delete async task of type BP non-abandonable task. That takes in a parameter in its constructor, which needs what we are. So takes in one of those. We happen to be that. Start background task is going to get us doing the work. Let's fill out the constructor for the non-abandonable task. Calling object equals BP task instance. The destructor is going to do calling object finished work dot broadcast, and then it's also going to set ready for destroy, because we don't want this sticking around after we're done. Now the meat of it is this do work, and by meat I mean one line of code. Multi-threaded work dot broadcast. And this should be it. This should be everything that we need in C++ to make this node be a thing. So I'm going to build. And with a build succeeded, we will reopen the editor. Okay, so back in the editor, we're going to go to content. We're going to make a new blueprint, an actor. We'll just call it, BP prime calculator. And if we go in here and you go to the event graph, you can see we have our little node. Now time to prove that it works. Let's just do a little setup. A box collision. And let's bring that, oh wait. First I just want to make the dimensions 100. That's good. Move it up. Alright, the box, we actually just want to make it so we can always see the collision. And when we have an overlap, we want to do something on begin overlap. That's all the time. And I want to have a separator. I want to have a branch with a bool that's going to be should use multi-thread. And we're going to need a function. Number of primes to find. Our function is going to be called find primes. And I guess it'll just have an input integer num primes to find. In here we're going to want to make a while loop. We're going to need a couple local variables. I'll just make them real quick to make this nice and easy. Is prime and primes found and current test number. So if primes found is less than number of primes to find, and we want to do something. First we're going to set is prime to true just as a baseline, and then we're going to do a for loop with a break. And our first index is going to be 2. And our last index is going to be current test number divided by 2. And moving on, out of our loop body, get the current test number and do the modulus of the index. And if that's greater than 0, or equal to rather, equal to 0, then the number is not prime. So we set in that to false. And then that's going to break us out of our loop here. Cool. After that, we're going to want a sequence in that sequence, we get if it's prime or not. If it is, what do you think we're going to do? Primes found. Here it is. We're going to increment primes found. And then we want to be able to get some feedback. So if primes found modulus of, let's just say 10. Every 10 primes, we want it to print how many primes. The modulus of that is equal to 0. Then we want to print, but tell you one thing, we don't actually want to print to the screen. For some reason it screws it up. Print into the log, I guess, is the better way. It always exits early. It doesn't do the whole function whenever I'm printing long. Print string is not a thread safe function. You can actually go to advanced here and click thread safe, and there's certain things that it'll yell at you and say like, yeah, this isn't, you shouldn't do this on a worker thread. You can, but you know, it's not really, you're not really supposed to. Anyway, what are we going to print? We're going to say primes found, and we're going to get the primes found. Beautiful. And at the bottom of all of this, that's why I have a sequence node here, we're going to increment the test number. Cool, so we have our function, and we want to maybe do it in multi-threaded or maybe not. I guess for now, we're going to shove this in here. Say, find the first 2,000 primes. And then finished versus multi-threaded node that we got here, where we will do this and then this. Hooray! We're basically at the finish line. Slap a couple of these bad lads in the scene. We got this one and this one. Ooh, one thing I forgot to do is make that public. So we go over here, well, interesting. Didn't really want that to be. There we go. Only one of them. Good. Get out my trusty old output log. And the one on the left should bog the system down, as we saw before. It'll even actually queue that. Let's see if it does it on this one. I think we need to increase our loop tolerance. Project settings. Loop. Just add a couple zeros. It's fine. Now we come back over here. We should be able to play the whole function out. Or not. So actually what we're going to do is we're just going to max this out. I think we're going to max it out and restart the editor. Alright, so restarting it, I think, kicked in the new loop settings. And just like before, we get all our stuff at once. Walk through this guy. We're just going to calculate those primes. Boom. So there you have it. Something else I wanted to touch on is the difference between C++ speed and BP speed. Like, it's nice to be able to do a multi-threaded function in blueprints, but you'll just see here like how much more efficient it is to do it in C++. So this is going to find the first 12,000 primes. We just did 2,000 earlier. Now 12,000. Main game thread, go. Oh man, and that's in C++, right? So 12,000 primes in like a second. So that's way higher than we got before. We'll do it on a worker thread, and you can see it just blows through it. You can just, bam. It's counting every 100 for this code. This is an older project. Now watch the BP do it. Oh my goodness. We're trying to get 12,000. And as you might guess, there's less and less prime numbers as you go higher and higher. So it takes longer going higher and higher. And it's literally, we can have another worker thread fire up, find all 12,000 primes, in between this one finding 100 of them. So blueprint code is so much slower for stuff like this. Basically, it's just because there's a cost, a performance cost every time you run a node. So if you're going to do a bunch of complex math or something, way better to do it in C++, where it's just kind of runs through the machine. It doesn't have to fire up a node every time. That's going to cost you. So performance aside, there are times where it's totally still applicable to do some heavy calculations in Blueprint. You know, you're not going to be calculating 12,000 primes most likely in your code. I actually use this myself for like a pathfinding system for open worlds where you're not going to be using a nav mesh where you can't really calculate the whole thing. So you can't just tell someone to go to the other side of the world if there doesn't exist a nav mesh already. So what I've got is, you know, all these guys. I'm going to get rid of the nav mesh. They're all calling an actor that's going to calculate whatever their best path is. And it takes like half a second. And when it was in the game thread, it was bogging things down. So I had to figure things out, and this is what we got. But this totally works. I mean, as you saw, it just happens pretty quick. But, you know, if this was happening on the game thread, we would not want that. And here is what that function looks like. Here's our node that we built. Calculate shortest master path. It's for each loops inside of for each loops inside of for each loops inside of, you know, it's just for each crossroad of a road we do a for each loop. So this goes a few layers down. It could honestly be more, and for each however deep we are, there's like all those roads need to be accounted for and all their distances, and you know. So for this, it works, you know, it's not too slow. And I'm able to get what I need. Well, that's it for this one. Thanks for watching. Please leave a like and subscribe if you're interested in seeing more videos. I probably will be making a tutorial on what this all is. So look out for that. Have a good day.